let us discuss neural networks. So neural networks are a machine learning model, but in an important sense, they differ greatly from all the remaining models. Because what makes neural networks so special is not so much their performance, of which much can be said nonetheless, but rather that they can be used to generate. For example, a quick search can find many pieces of art which are generated using neural networks. Another example is the currently famous ChatGPT, which is based on a neural network and is a seemingly intelligent chatbot which can give informative responses. For instance, a human can ask the chatbot ChatGPT information about the number 1234, and it will produce information about this number without being explicitly programmed to say these things. When it comes to performance, neural networks are not always the best performers on certain types of data, but on others, such as vision, neural networks have been the famous best performer. So with that, let's discuss the basics. Very simply speaking, a neural network has an input, here depicted by the x's. So these could be the values of pixels, could be their color in RGB, or it could be just 1, 0 with the pixels split into 3 colors, or this could be the sequence of letters. This all depends on the application. Given these numbers, there's now a collection of weights depicted by W's that is used to multiply and add these xi's. There's an addition of b's, which is some other addition of numbers that will later be determined as parameters. And after performing these additions and multiplications, what we would call a linear transformation, or to be more precise, affine, because we add the b's, this linear thing, this linear result, is then activated using a nonlinear function, ReLU, hyperbolic tangent, and so on and so forth. So far we took our numbers, multiplied them by weights, and added them to each other and to other weights. Then we performed this activation, which is nonlinear, and now we have a bunch of new numbers again. And we can repeat this process several times. Each time we do this, we call this a layer. And finally, we have an output. So in this sense, this is a mechanical procedure with parameters called weights, some activations, and finally we get some answer, which initially has not much meaning. Training means finding W's and B's such that when you put in your initial input, the result is actually correct. In other words, we are tuning these W's and B's so that we get the correct answer. The process for doing this is called backpropagation and is an efficient process for doing this, the training. And this is ultimately what training the neural network is. Select an architecture and then compute W's and B's that fit the data. And afterwards, of course, we must ensure that we are not overfitting. So that is the basics of neural networks. Some intuition is given by the neural networks of minds, but this intuition is optional for understanding this process. Once we have all this, we can go ahead and classify digits and take things from there.